Okay, you've probably seen the headlines, right? AI is moving at this just breakneck speed. And one of the biggest buzzwords getting thrown around is the context window. It's basically the AI's short-term memory. And the numbers we're seeing, they are getting just astronomical.
I mean, we're talking about models with context windows of 1 million, even 10 million tokens. To put that in perspective, that's like an AI reading the entire Harry Potter series several times over in one shot. So you'd think, problem solved, right? We can just shovel all the information in there, and the AI will just figure it out. But, well, there is a massive catch.
All right, so to really get this, we've got to break down two different ideas. First, you've got the maximum context window, the MECW. This is that huge number you see in the headlines. It's the absolute limit of what you can physically stuff into the model. But then there's the maximum effective context window, or MECW. And honestly, this is the one that really matters. It's the tipping point, the spot where adding even one more piece of information starts to make the AI dumber, not smarter.
And here's the kicker. Recent research? It's just wild. They found that for a lot of real-world tasks, that effective window, the part the AI can actually use properly, is more than 99% smaller than what's on the box. Seriously, let that sink in for a second. Over 99% smaller. It means we have all this gigantic space, but most of it is worse than useless. It's actually hurting the AI's ability to get things right.
So, what do we do? If bigger is better is a myth, what's the answer? Well, it means we need to get smarter. And this is leading to a whole new field, a real shift from just, writing good prompts, to actually engineering the entire world the AI sees.
Yeah, for a while now, it's all been about prompt engineering, right? The art of crafting that one perfect sentence, those magic words to get the AI to do what you want. But this new thing, context engineering, it's a completely different ballgame. Think of it less like art and more like science. It's not about one little instruction. It's about designing the whole shebang, the entire information environment, so the AI has exactly what it needs and nothing it doesn't.
Andrej Karpathy, a huge name in AI, came up with the perfect analogy for this. He said to think of the LLM as the CPU of a computer, the brain doing all the heavy lifting. That means the context window is its RAM, its working memory. And you know what happens on your computer when the RAM gets overloaded with junk, right? Everything grinds to a halt, it starts crashing. It's the same exact idea here. The goal is to be super strategic about what you load into that RAM.
Okay, so let's get into the weeds a little. What's actually in this working memory? What are we loading into the AI's context? Because trust me, it's way more than just the question you ask it. Let's take a look.
So when an AI agent thinks, its context is a cocktail of all this stuff. You've got the main system prompt, or instructions, of course. Then the user's input, the immediate chat history, what we've just been talking about. But then there's also long-term memory, stuff pulled from a knowledge base, definitions of what tools it can even use, and then the responses from those tools. Oh, and any rules about how to structure the final answer. It's a lot. A really complex, moving puzzle.
And what happens when you just dump all of that in there without any thought? You get something called context rot. It's a great name for it, actually. The AI's attention just gets totally diluted. It's like trying to have a serious conversation in a room where 100 people are shouting. The AI can't figure out what's important, and its accuracy just tanks. This is exactly why we see that shocking 99% drop in effectiveness.
So this is the whole point. We have to stop being passive users and start being active architects. We have to engineer this context to keep that context rot at bay so the AI can actually do its job right. So how do we do it? Let's get into some of the core techniques. When you get right down to it, there are really just two big puzzles we have to solve. First, how do we pick the right context? Out of all the mountains of data out there, how do we find the one perfect nugget of information? And second, once we find it, how do we make that context fit into the space we have? Okay, for selecting the right stuff, we use this really smart three-step dance. First, we define. We don't just throw the AI into a library, we give it a table of contents, a clear list of the tools and knowledge bases it can use. Then, based on your question, it does the select step. It looks at the list and says, aha, for this I need the product documentation tool. And only then, as the final step, does it retrieve. It goes to that specific tool and pulls out only the info it needs. This way, we're not flooding the system with junk from everywhere else. And what about that second challenge, making it fit? Well, we've got to be clever there too. We can't just throw a whole book chapter into the context. We use techniques like summarization to boil it down to just the key takeaways. And ordering is unbelievably important. Research shows that AIs pay more attention to things at the very beginning and very end of the context. So we put the most critical piece of info right where we know it's going to look. It's all about making the important stuff scream and the noise whisper. Okay, that's great for pulling in outside info. But what about the conversation itself, you know? How does an AI remember what we were talking about 5 minutes ago, or even yesterday? Because if it can't, it's not a very useful assistant, is it? We need a memory strategy that doesn't just hog the whole context window.
And the solution's pretty cool. We basically use different kinds of memory for different jobs. For example, you have vector memory. This is awesome for finding past conversations that are kind of similar to what you're talking about now. Then there's fact extraction memory, which is super literal. It pulls out key facts, like your name is Sarah or you prefer short answers, and keeps them in a list. And finally, you might use static memory to nail down one single critical thing that should never change, like you are a helpful customer service bot. It's all about picking the right tool for the job.
So why do we need all these complicated techniques? Why all this engineering? Well, it brings us right back to that bombshell finding from the beginning. That effective context window is not one size fits all. It changes, like wildly, depending on the task.
And this is probably the most important thing to understand. There's no magic number for a model's good context size. The amount of information an AI can actually handle well is completely tied to the difficulty of the job you're asking it to do. Just look at this chart. It tells the whole story. If you ask the AI to do something simple, like summarization, it can handle a ton of context. The effective window is pretty big. It's good at skimming. Now, if you ask it to do a needle-in-a-haystack search, find one tiny fact in a huge document, the performance is still pretty good, but the effective window shrinks a bit. But now look, ask it to do something with multiple steps, like filter a bunch of information and then sort it. The effective context window just falls off a cliff. The AI gets overwhelmed, and its ability to perform the task just collapses. And all of this leads to what is basically the golden rule of building with AI today, something called minimum viable context, or MVC. The goal is no longer to cram as much as possible into the context. The real goal is to figure out the absolute smallest, most powerful, most relevant little package of information the AI needs to nail the one specific task you've given it. Not a token more, not a token less. So what we're really talking about here is a total mindset shift. We're graduating from being prompt crafters, trying to find that one magic spell. Now we have to be architects. We're designing the entire information space to help the AI think clearly and do its job one step at a time. And I think this leaves us with a really powerful and kind of counterintuitive question. For so long, the race in AI has been, how big can we make the context window? Everyone's chasing bigger numbers. But maybe the real question we should all be asking ourselves is, how small can I make the context and still get the perfect answer? Because that right there is where things are headed.